Hello everyone, my name is Aman Kachru. I am a member of ISA-VESIT. Today I will be giving a short tutorial and explaining the prediction model that I have made over here. This prediction model helps us to predict the customer churn rate of a company. So first, this is the data set that I've used in it. It's customer churn.csv. These are the header included the essential libraries here. Then I've just used Google Colab to import my CSV file. So this is the CSV file that I've imported. It's the first 5 rows. It contains 21 columns. And here we can see that its size is around 7043 and 21. That 21 is the number of columns, but 7043 is the number of rows. These are the columns and the data types of the columns. Here I've described the data frame that DF is a data frame that I'm using over here. I've described it to get the count, mean, standard deviation, minimum and the maximum value for the numerical columns. After that, I have calculated the percentage of the churn. For example, 73 is the number of people who are not churning and 23% are the people who have churned from my data. This is the numerical form of the churn rate. After that, I made a copy of my data frame and made it converted into numerical values so that to check if there is a null value in my data set. So here you can see there are 11 values of total charges that are null. So I just printed all the 11 values here and then simply deleted them. So as you can see now, the size of the data frame has reduced by 11 rows. After that, I just started doing some binning by taking consideration of the tenure column, because it was very vastly distributed, equally distributed among bins. So these are the bins that I formed. It's 1 to 20, 1 to 12, and then 25 to 36, and so like 13 to 24, 61 to 72, and so on till 72. It's from 1 till 72 with a 12 interval gap. And then I dropped the tenure and the customer ID, because customer ID has no significance with my churning rate. After that, I made some graphs. Let's take this paper as billing graph into consideration. Here I've just seen how many people are churning and how many people are not churning from the company. This is a no and yes graph. So if the people are using paperless billing, in that these are the number of people. Blue is the number of people who are not churning, and orange is the people who are churning. And similarly for non-paperless billing. And similarly, I made it for each and every column in the table. As you can see over here, each and every column has its own independent graph. So after that, then I made this. After that, then the churn here, as you can see, the churn rate here was in yes and no. So I just converted it into ones and zeros for better understanding and better using in the model. After that, now was the time to process the categorical values. Categorical values generally refer to the values that have a fixed outcome. For example, if we're talking about gender, the gender can be male and female. So when a person or a customer is female, she can't be male. So when it's 1 in female, it will be always 0 in female, and similarly for other values also. So then I plotted a graph for monthly charges and for total charges using CMON libraries. And then this is a heat map for the further understanding of the data, as it tells me each and every dependent variable, which variable is dependent on which variable. After that, now comes the part of actual model building. So the thing that I've done till now is the cleaning of data. I saved the data into a new CSV file called as analyze of CSV, and then I read this CSV into a new data frame DF1. Then this is the column that I got. So now this data frame has 52 columns and 5 rows. But as you can see, here's a column that's unnamed, so I need to drop it because it's of no use for me. So I just drop this unnamed column, and now comes the time for giving the x variable a value and a y variable some value. So for x variable, I gave whole data set excluding the churn value, and y value will be our churn value. After that, now I just splitted the data into the training and the testing data. The split was of size 0.2. That means 80% of data was used for training the model and 20% was used for testing it. Then I used some classifiers. For example, DTC as decision tree classifier. I imported some libraries, and then initialized the decision tree classifier over here, and then fitted the X train and Y train values inside the model. Then I got a then I predicted using this X test to get some prediction, and then I compared this prediction with the Y test that I've already said, so that in order to get a classification report. Here I got precision, recall, F1 score and support. Here is the value of what precision, recall, F and F1 score is. This TP is true positive, FP is false positive, FN is false negative, and there is one more term that's TN, that's true negative. These are all of the terms in the confusion matrix. Accuracy of the model that I've used of this particular algorithm, so it comes out to be 71.5. That's quite a less accuracy. So then I used a smartening method including decision tree. Smartening basically is picking up some data of equal amount. For example, if I pick 10 rows of non-churners, I will pick the 10 rows of the churning data, so that the data is balanced. I resized the sample and made some new testing and training data, and then fitted it in the smartening model this time. And then I got some score that was 0.944 out of this smartening data, and I made a classification report similarly, and then I got accuracy of 0.94. So the accuracy of smartening model came out to be 94.42. That's quite a good accuracy. So smartening was working for me. Then I already made all this thing like random forest classifier. I made it simply, and then used smartening including into it. Then I used logistic regression model similarly. Then I used k-nearest neighbor. These are the 4 basic algorithms that I've used in my model. After that, I calculated accuracy of each and every part, and I just made a data frame out of all the accuracies, and then arrange it according to the score value. The score value is the accuracy. So as you can see here, the decision random forest with smartening has the highest accuracy of 98.11. So that was quite a good accuracy. So I just made my model using this random forest with smartening. My final model will be made using this. So now it was time to save my model using pickling method. So I just imported the pickle library. Then I gave my model a name called as ISA-VESIT. Then I just put in all this model into this model.sce file. Then in order to check my model that it's working perfectly fine, so I just loaded my model and just checked the accuracy. The accuracy that I got was 98.116. That same accuracy as the random forest with smartening. So that concluded that my model was perfectly working, and the RF classifier that I've used was saved into model.sce. Now this model.sce file can be used further using some Python code or using Flask in order to make a front end part, and then used over there also. So thank you, that was all my model.